This is section 2.4 in your textbook, which goes over how to solve other types of equations, like absolute value equations, radical equations, and fractional equations. So in this video, we will go through all three types, a little bit of review with them, some examples, and at times some properties. So if you use this little outline here to help organize your notes, that might be easier to go back and read later. I'll end with some common misconceptions and mistakes, and then I'll have you summarize through Edpuzzle. To review absolute value for a minute, let's just remember that an absolute value refers to something's distance from zero, and for our purposes, we'll always consider distance to be a positive number. So that's why everybody always remembers absolute values are positive, but there's this common mistake that they make. When they think that, they think, oh, I should make everything inside positive, but don't do that. It's the number outside that's going to change. Everything inside the absolute value is going to look exactly the same. You're just going to set it equal to the positive version of the distance and the negative version of the distance. So you'll get two solutions, one that's on the positive side and one that's on the negative side. Now, sometimes the final solutions you get aren't both you don't get one positive, one negative, because something about the equation has shifted us around on the number line, but the two solutions come from the fact that you have a positive version and a negative version of that distance. So here's the example from the previous slide, blown up a little bit here. You might want to pause and maybe try the example before you look through all of the work. You'll see that the negative 2x plus 7 appears both times. And by the way, I would encourage you to write down this example and maybe highlight it so it's something you can come back to. Negative 2x plus 7 stays the same. It's the 25 that becomes both positive and negative. So we have a positive 25 and then negative 25. And that came from the number outside the absolute value. Once you have the two equations set up, you're just solving equations like you've been doing since pre-algebra, where you get x equals negative 9 and x equals 16. There's some properties of absolute value. You might want to pause and take a look at some of these and jot these down. There's not a lot of commentary I can give you for these. I might highlight one in particular that you might forget, which would be the fact that you can break up multiplication and division into two separate absolute values. Sometimes that can be helpful. All right, next section, radical equations are the ones under the big radical sign. That means the variable has to be under the radical sign. Sometimes there will be extraneous solutions, and this happens after raising both sides to a power. So you're going to want to go back and check all of your solutions to make sure you don't have any extraneous ones. This is usually solved by using inverses. So, for example, the inverse of x cubed is the cube root of x. So those two can be used to solve the inverse of anything to like an nth root here. So we could have like the fifth root of x would be raising something to the fifth power. Also, it might be helpful to remember that exponents, the radicals can be rewritten as like fractional exponents. Sometimes that's helpful when you have to put things into your calculator. You can use a little caret for that. Also, in word problems, and I'm going to ask that you jot this down and remember it. Remember that the Pythagorean theorem, a squared plus b squared equals c squared. You'll use that in word problems for radicals. Here's an example of a radical solution being solved. You can see that since it has the cube root, both sides are being cubed. When you write down this example, I would highly recommend you write down this commentary so that you can star this where you have to isolate the radical first. Very important. And then you should get down to a point, in this case, they factored and you got 2 solutions. You should plug both of those back in to check. So there's my quick check here. Both of those get balanced equations, so we should be all good. All right, next up, fractional equations are ones where you have polynomial algebraic expressions in both the numerator and denominator. And we want solutions. This is what you should write down. This part's the important part here. We want solutions that work for the denominator, or work for the numerator, and don't create zeros in the denominator. That's bad. Zeros in the denominator are bad because you can't divide by 0. Remember that. You can't divide by 0. So, very important. Highlight it, circle it, star it, find solutions to the numerator, and then check those against the denominator. Here's an example of solving a fractional equation. Here's the solution from you should pause and jot this down if you need to. Here's the solution from the numerator, 2 solutions, because it's a quadratic. And then both of these get plugged back into the denominator, checking in the denominator. This one gave us an unbalanced equation. This did not actually equal 0, so that's not a solution. Not a solution. But the 1/2 did equal 0, so this one is a solution. Just to reiterate some of our common misconceptions, don't change the sign of anything inside the absolute value sign. Make sure in radicals and fractionals you're checking for those extraneous solutions. And also in radicals, look out for non-real answers. If you plug something back in and you end up taking the square root of a negative, usually exclude those. On Edpuzzle, I'm going to ask that you summarize what you've learned in 3 to 5 sentences. Try solving this equation, and then I want you to tell me something you still don't understand or something you think you might make a mistake on.